I'm going to give you a position versus time graph, and you have to explain, you have to understand it, and you have to calculate the displacement as well as the velocity. So let's get it started. So position versus time graph. So let's make the elapsed time 10 seconds. And let's say this is -1, this is 0, this is 1, this is 2, this is 3, and this is 4. Let's stop here and let's make elapsed time. Let's object in motion for 10 seconds. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right. So I don't need them. And I don't even tell you what type of graph it is. So it is very important to inform that. So this is a position versus time graph, or sometimes we call DT graph. Position is in meter and time is in second. All right, so let's say our object is at 0 second, our object is at position 2 meter, and it remain at position 2 meter for 3 seconds. Okay, it remain at this position for 3 seconds, and now it decided to move. It decided to move up. So from 3 to 4 seconds it move up. Now its new location is 4 meters. To be more precise, its new location is 4, 4. Okay, this is how you give the position: 4, 4, 4 seconds, 4 meters. Now from 4 seconds to 5 seconds, it move backward. And let's say it from 5 seconds to 7 seconds, it stay there. It does not move at all. And let's say from 7 seconds to 10 seconds, it moves backward again. Now, how many we're going to divide and conquer to find here? We want to find the displacement, the total displacement. In order to find the total displacement, the easiest way to find the total displacement is divide and conquer. So I'm going to divide this graph in 1, 2, 3, 4, 5. Yeah. 5 section. So let's divide this one. This one, let's call it A. Let's call this one B. Let's call this one C. Let's call this one D. And let's call this one E. Okay. Now I'm going to make a table. I'm going to write the displacement, and I want to find the displacement at A, B, C, D, and E. And I also want to find the velocity. Velocity at A, B, C, D, and E. All right, so what is the displacement at A? Remember displacement equation, displacement is d final minus d initial. So d final is 2 and d initial is 2. So displacement over here is 0. What about the displacement right here? Right here. D final is 4 and d initial is 2. So the displacement is 2 over here, 2 meters. At C, D final is 3, D final is 3 and D initial is 4, so it's -1. And as you know that displacement can be negative. At D, displacement is 0 because object never changes its direction from 5 seconds to 7 seconds. Now let's see at E. D final is -1 and there is a negative sign over here, and the D initial is 3, so it's -4. Okay, so now we're going to find the velocity. Velocity is displacement over time. Okay, displacement over time. So 0 over 3 is 0. Now 2 over, this is 1 second from 3 to 4 seconds. So 2 over 1 is 2. -1 over also 1 because elapsed time is 1. -1 over 1 is -1. 0 over 2 is 0. -4 over 3. -4 over 3. -4 over 3. So -1.3. So we can write it -1.3. Or we can write -1.3. All right, now we can find the total displacement. So the total displacement is 2 minus 5. So total displacement is -3 meters. Let's see whether we can find the total displacement in a different way. This is my final position. This is my initial position. Okay, so let's see whether that gives us total displacement. Displacement is D final minus D initial. D final is -1 and the D initial is 2, so -3. All right, so they are the same and they should be the same. Now let's find the average velocity. 2 minus 2.3. So average velocity is -0.3 meter over second. So let's see whether we can find the average velocity a little different way. Average velocity is the total displacement over the elapsed time. Total displacement, we found that -3 meter, and elapsed time is 10. So this is also -0.3 meter per second.